So the second bit, the last bit before Smoko, you'll be glad to hear, is I'm going to give you a bit of a tour of the technology. So I've mostly talked to you about satellite sensors, but the basics to EO also refers to the sensors we put on planes. So aero photography is the most common and the oldest forms of Earth observation, actually. And we mostly do that from flights, but you can also put all sorts of other sensors like LiDAR, radar, all sorts of fancy stuff. And a lot of the hyperspectral sensors that we use are collected from planes as well. And then that's a picture of Neil and his drone at the bottom there. Drones have not been around for very long, believe it or not. 2005-06 was where we first started using drones for Earth observation beyond military exercises and recon, stuff like that, which the Russians and the US mostly did in the 50s and 60s. But now it's become a little bit of a toy. You can buy them on Amazon. But Neil will go over the regulations and the stuff that you can and cannot do with drones. But there are limitations to all three of these, I guess, which I'll talk about after Smoko. So how many satellites are there currently in space? So there are 400 satellites, and by satellites I mean the big, multi-ton missions here. There are about 2,000 small satellites currently orbiting Earth, and they're about this big. And more of those are being launched constantly all the time. And those missions are not designed to last. So the satellites that I'm talking about here probably have mission time of about 6 to 7 years, but most of them last a lot longer than that. Just because in space you've got nothing that really affects them apart from debris. Ironically, and with all the other stuff that we're launching into space, debris is becoming a big issue. And debris is something the European Space Agency are monitoring, and only them are monitoring. And they have this videograph of all the debris that's currently circling our planet. And the problem is that even a millimetre or nanomillimetre sizes debris can cause massive damages to satellites. So they constantly have to monitor where all those tiny little pieces are and move them out of the way, especially things like the solar array, because that's where the satellites get power from. So if any solar arrays are damaged, then the life of your satellite is severely impacted.
Sorry,
yeah.
Who launches those satellites?
Lots of people.
I mean, does the Richard Bransons of the world, can they launch?
So the small sats are all mostly commercial companies doing that. So the biggest is called PlanetScope. So they successfully launched 120 satellites at one go on an Indian launch 2 years ago. But there are lots of other companies that are starting to launch things into space. You may have heard of a New Zealand company who launched a glitter ball into space to try and make the starry night more starry, which impacts everything we do from space, including communications, the Hubble telescope, looking out into deep space, everything. So that was a complete nightmare. So it's becoming a lot easier to launch things into space. So there is a consortium of people that manage who can launch what into space, but it's led by the US. So for example, the resolution of satellite in space is capped at 31 centimeters. We can't launch civilian satellites with anything that has a spatial resolution of less than that because the US military won't let us. Military operations exist at much higher resolution, but we don't have access to those. Yeah, so you have 31 centimeter pixel size from space.
You still see yourself moving along the road?
Yeah. So the technology is brilliant, and better technology exists, but we are restricted by what we can launch, believe it or not, even after the New Zealand story.
That's a question.
Yeah.
So we're putting this stuff into the sky.
Mm-hmm.
Point we've actually been out polluting our skies. We're polluting
Yep.
polluted seas and now they're polluting
Yeah.
the atmosphere. There's not regulations on how much you can put out there these days?
Not at the moment. I think it's currently in discussion. So a lot of countries don't even have laws in place for a space program. So the Japanese, who have been launching satellites for decades, are only just getting their space policy up to date, for example. The US, we in Britain do. Most of the European countries that have space activities already have laws in place that do monitor this. And like I said, the European Space Agency is the leader on this. And because they monitor the debris, they see this as a threat, exactly as you say. And every satellite that is now launched into space has to have the ability to come back into the Earth's atmosphere once it's finished its mission. So that is not implemented by all currently, but NASA and the European Space Agency do launch things that can come back into the Earth's atmosphere. The Chinese have and the Russians have a big space program, and they're not currently signed up to doing this, but the Russians do generally comply with the US when it comes to their space activities, because they launch all their launches either from Russia or the US. We've been working together for decades on this. So it's the Chinese we need to watch, I think. Their space station, for example, is one of the biggest causes of debris that's currently in space because it blew up about 5 years ago. And a large component of the material of the Chinese space station is still in orbit, but in bits. So the main chunk of that came back into the Earth's atmosphere last year at some point. So hopefully some of the other bits, there is technology out there that's being trialled to try and grab debris to bring it back to Earth, but it's very, very difficult to do so, because the minute you have an impact in space, you create more debris. So it's logistically a very, very difficult thing to do. But the four main areas of monitoring are meteorology, so most of our weather forecasting is done from space, land, marine, and the cryosphere. So you will have missions that are specific to these areas. So Sentinel-2, for example, is a land monitoring mission. Sentinel-3 is a marine monitoring mission. So there will be caveats to those missions if you know where to look. So I always show this slide just because, like you say, we are polluting our Earth and polluting our skies. Satellite data has the power to give you this information over time, regardless of where you are or who you are. This is in Brazil, and the deforestation rates over time are enormous. And the Brazilians have their own space program and monitor deforestation rates on their own, but this is a Landsat time series. So Landsat has been in orbit since 1972, at 30-meter resolution since 1982. So these are the sort of time series that you can produce and monitor how we are impacting and changing the Earth's landscape. So it's quite drastic. So a similar time-lapse of South Georgia. So the glacier retreat that Ross was talking about was the one here. So this is the power of satellite data. You don't have to pay helicopters or whatever to go and get there. This is free data, so you can initially have a look at this to see if there's any changes. And then if there's any changes that are concerning for you, then you can act and do something else, you know. So visual applications of the data, like I mentioned, there's a lot of them and they could be quite powerful. So something else that we can do from space is monitoring the atmospheric column. So in this part of the world, you've got very good air quality compared to the rest of the globe. So this is actually carbon monoxide, and it's a year's worth of Sentinel-5P data. And carbon monoxide is a byproduct of forests. So a lot of the tropical forests have very, very high emissions from carbon monoxide. But India, China, what's their excuse, you know? It does skew things when you show things at this level. So there may be some local effects happening here, maybe from burning the tip or something, or all the boats, the fishing vessels that come by. That has massive capacity to impact air quality in other countries. So I'm assuming it must do here too if they come close by to Stanley. So this sort of satellite data can give you the power to monitor this if you choose to do so. You don't have to, but it's available for you if you wanted to. So I already mentioned MODIS, so you can monitor fires from space as and when they happen. So this is actually the Paradise wildfire in California 2 years ago. And this data is very high commercial data, but it's been made available for free through the Disaster Charter. So the Disaster Charter is a piece of legislation that all the satellite providers are signed up to. And if a natural hazard or a disaster event has happened, then we can activate the charter, and then the satellite providers will give you as much satellite information as possible over that probably a 2-week window after, or perhaps even before the event, if you know it's something bad is coming. And then the commercial satellite providers will give you access to their data for free if you need that spatial information. So this is what happened here. A fire has occurred. So the orange area is where the fire damage is. Yellow is expected fire damage because it was still burning when this map was created. And the red area is where all of the population within this area lived. And these are maps that are all created from space data, but it allows you, it gives you the evidence, and it gives you capacity to monitor impact over time. So you've got a baseline extent of this fire. You can then go back to satellite data over time to see how fast or how slow it's recovering, the habitats and the population, the houses, when they're being rebuilt. So monitoring things like this in areas like this are probably in the future going to be even more critical with climate change. But I know peaty areas in particular, from experience in the UK, once a peat bog catches fire, it can burn for a very long time. And we in the UK have a lot of issue with wildfires at the moment. And perhaps this might be an issue in the Falklands. I know you've got a lot of peaty areas. You've got less opportunity, perhaps. Campfires from lightning or whatever. So you can definitely monitor these from afar. And if you're lucky to have enough to have an image, you can perhaps send data to your fire department and tell them where they need to approach the fire. You know.
Actually, that's brilliant.
Yeah, this data is used for that sort of thing on a regular basis. So this one might also be close to home. So counting albatrosses from space. So this is a commercial image again. It's Worldview 3, so it's the image with the 31 centimetre pixel resolution. Now, the white dots here are all birds because the albatrosses are big enough to be picked up by the resolution, but they're also white next to a dark background. So your ability to do this sort of stuff is heightened because of the context and the conditions. But here they just counted them. So they opened the image and manually counted them. And I'm going to show an example with a drone later where you can automatically count them, where you don't have to manually count them. So I think this was done off an island off the south of New Zealand, I think. But it means that you have the capacity to do it here if you're willing to pay for the imagery, I guess. So the other things we can do with satellite data, this is active remote sensing, not passive remote sensing. So this is creating detailed terrain models, but mostly using radar data. So we send microwaves down to the Earth and measure what comes back. And you can create all sorts of maps in a GIS, and it's very simple GIS based on a terrain model like this. Now this, again, is commercial data. But I know South Georgia have a digital terrain model put together from different data sources by BAS. For the Falklands, you're missing one of these. I think you're stuck with the free 30-metre resolution SRTM dataset, which has gaps in it and all sorts of problems. But it would cost something like £500,000 for me to buy one of this for the Falklands. I did look into it. Yeah, I did look into it, and that's how much it costs. So obviously I'm showing you this data from other smaller islands in the British Overseas Territories just because I could afford to buy them for those. But the Falklands is missing one of these. So perhaps, we can build a case to build a proper digital terrain model just because you can do so much stuff, not just by having terrain information, but for modelling all sorts of different things. So talking about using satellite beneath the water, you can do satellite bathymetry beyond the water up to about 15 metres of depth. It works well in some places, not so well in others. So sedimentation, so we can't do really this around our UK waters, for example. We could do it for some of the islands of the west coast of Scotland, but that's about it because our waters are too murky for this sort of technology to work. But we have a UK hydrographic office that collects data on a regular basis. But this could work in some of the estuaries. Oh, it's gone mad. Some of the estuaries, perhaps in the Falklands, if the water's clear enough. But if you've got kelp forest, then that severely limits how much of the sea surface you can see. So there's lots of limitations to this, but it's worth exploring how much you can do, I guess, if the data doesn't exist. And I guess that's the key point for satellite data. It gives you an avenue to do something if the data doesn't already exist quickly on your laptop if you really needed to. So another type of active remote sensing that's particularly critical in South Georgia, because I've been talking to you guys about this, but using radar data to detect vessels. So this is a Sentinel-1 image, and you can see all these tiny dots are vessels. It's very difficult to tell the type of vessel, but you can definitely count vessels. And Sentinel-1 can see through cloud, so it's not limited by the passive remote sensing types. But in the UK, you can also see the wind farms that are out to sea. But this is temporal merging, like I mentioned before. So all of the shipping routes, the ones in Bright in particular, so a lot of the ships, they leave their ballast water and stuff out here and then go into the port. So that's what you can see here. The two lines are the main two shipping routes going through the English Channel. So there's lots of stuff that you can potentially do with this. It's a free source of data. And Sentinel-1C is actually going to be launched with an AIS sensor on top of it as well, which makes it easier for you to do vessel detection specifically. Now, because they're putting an AIS sensor on, it's not going to be launched this year as planned. It's going to be launched in 2021. But it means potentially that mission has added it to its functionality in the future. And I imagine this sort of thing will be very, very useful for the Falklands as well. So coming down from space, more to what we can do on the surface. The video for this isn't working, but it was a 3D point cloud of inside Kew Gardens. And if the video is working, you would be able to see the spiral staircase. But this is an active type of remote sensing as well, and it sends out a light pulse, not a microwave like the radar, and measures what comes back. But it's very, very useful for monitoring, for monitoring tree structure, canopy structure, that sort of thing, which you don't have much use for in the Falklands, but there could be other things that LiDAR datasets could be useful for. I know that the Hydrographic Office uses LiDAR to collect their bathymetry datasets, and they've got these high-tech LiDAR instruments that can travel through the water column in the blue part of the spectrum. But this is done by using a handheld sensor that's sending light pulses out at a certain rate per second and records what comes back. So the detail of it is quite spectacular, and this sort of technology is not cheap. So I would imagine it will become cheaper over time as there's more competition, because it's in an industry type of sensing, if you like. A lot of academics use it because they can afford to do so, but commercial or operational use of LiDAR are still some way off. In the UK and in the Scandinavian countries, we do provide LiDAR data openly available, but mostly as terrain models or digital surface models instead of the full 3D point cloud. But that's mostly because they're anticipating that users won't know what to do with the volumes of data here. You need specific software and specific set of skills to be able to do anything with it. But it's cool. Yeah, BAS probably have all sorts of sensors like this. Yeah, very academic. There we go, yeah. And it's very good for inside caves and stuff like that as well, if that is a requirement for anybody. You can, on a boat, go with these handheld sensors and it'll map the inside of the cave for you, because that is something we cannot do from space, because we can only see the surface. And the last bit of the tour of technology, so again, this is counting gulls, but this is drone data, and this was a bit of piece of work done by Natural England. So they collected a drone image over an area where they wanted to know how many gulls there were. Now this was done using image J. So if you play around with the brightness of pixels in image J, you can do a count in an automatic way, so you don't have to sit there manually counting things. So image J has identified all of these as birds. So it's not perfect because you've got some birds in flight that are not being picked out, but it captures most of the birds. So now I'm going to ask you, how many do you think there is in this image? Anybody want to hazard a guess?
5,000.
Close, no. Less than 5,000.
3.5.
Ooh,
3,500.
close. Anybody else before I give you the answer?
3,724.
No, too far, the other way. 3,099 according to image J, but I guess you can count 1, 2, 3, 4, 5, 6, 7, 8 more. So automated analysis with this sort of stuff is possible, and I know a lot of people are using with just photographs, not necessarily drone imagery, from helicopters to count flamingos and all sort of stuff using image J. It's an open source software, so you don't have to pay for it. And it's a very, very powerful image processing software. It's designed to work with photography from photogrammetry, but you put in an image from space and it does the same thing. So in the future, if you're interested in doing this sort of stuff with your work, might be very useful for you.
Yeah.
And that's the end of Tour of Technology. Any questions on anything I've showed you? Or any questions about your own scenarios where I can attempt to give you an example of the best type of EO for your...
Two starters.
Ooh, Neil.
So the disaster charter
Yes.
defines a disaster. So for example, if there's an oil spill around the Falklands.
Oil spill counts as a disaster, yes.
I guess there's a sort of list of what.
There is, and it doesn't have to be natural. It can be human-induced events too. So anything that causes damage to human life in particular, but also to the environment, included in the disaster charter activation.
JNCC's been doing that in the Caribbean, haven't they?
Yes, so we, as an organisation, can activate the charter on behalf of British Overseas Territories if they feel like they're not able to. We can set you up with the UK Secretariat to get training on how to do that if you're interested, or you may already be signed up, I don't know. But you can come to us and ask us about that if you're interested in signing up to becoming a project manager so you can activate it.
Has that all been communicated to the OTs yet, or is that still...
Only for the ones that are impacted by the 2017 hurricane season, because we've only got a limited capacity at JNCC, so only for those areas. But obviously, we have the ability to do that, and it will be open to all of our British Overseas Territories if they see fit. You just need to come and ask us about it.
And there's no like size limit. So say if there was a farm that had on a headland.
There's no size limit.
None. Okay. That's
Yep.
really cool. Brilliant.
Would we have to determine here how bad a fire is in terms of carbon impacts in order for it to qualify as a disaster? How does the...
Well, it's the loss to human life. That's the top of the list. So anything environmental impact-wise is further down the list, but it still means you can activate it. But if there is danger to life, then you can activate, regardless of scale.
Just to pick up on the satellite-derived differential, you did try that in the project.
We did, yes.
Like proof of concept. We tried it. Was I right in thinking one methodology, and there are many ways to...
Well, there's at least two that I know of, yeah.
So the method we tried wasn't overly successful, in the conclusion. I guess we haven't tried the same method yet.
But also, I think the main thing for the Falklands is that as far as I know, we have very little understanding of the water types around the Falklands, which would impact the type of model you use for satellite bathymetry. If that data exists somewhere, then let Neil know, I guess. But if it doesn't, then that would need to happen before any success.
Like CTG data, isn't it?
Yeah.
So
Yeah.
That data may exist, whether it's been analysed, I don't know, but yeah, that side which I guess we need to be done first before.
But you're talking about coastal stuff.
Yes.
Yeah.
Well, stuff that up to 50 metre in depth. Before any deeper than that, it won't work. So.
No, I mean, there's how you know, deep ocean bathymetry is a different type of.
Well, yes, exactly. Yeah.
Sea surface altimetry to look at.
Yeah.
You know, all the different models, but I think I don't know how close and short that comes to 200 meters.
Well, the coastal region is the one that's always misses out in these because the methodologies and the stuff we use at sea work at sea, but then they have limitations when you come up to the coast and vice versa on land. So it's always that coastal fringe that misses out, regardless of what we do, you know, even if it's Earth observation or not, I think. So I think, yeah, so coastal areas are probably the next frontier for a lot of research projects in general, just because that's beyond deep sea where we've never mapped and whatever, is the next feasible place for us to carry out research, because we can get to it at least. And technology is improving all the time, both from, you know, what we can put on boats and what we can do remotely. So
just to follow up on that, in terms of if the military ever allowed us to release some of their advanced satellite, you know,
no, that's never going to happen.
Yeah, I was just saying that.
But would that actually improve our coastal picture if that technology was available?
No,
Okay. So it's
I don't
really
think so.
Next level.
Well, I think we need to better utilise the technology we've got in the coastal fringe, because it's not that we can't do stuff, it's the drive to do it isn't there yet, I think, because traditionally we've either been land or marine. And even at JNCC we have that divide, because I sit in the terrestrial part of JNCC and I find it very difficult to work with the marine side of JNCC just because we work in so different ways. And it's that lack of communication and common ground that prevents this sort of research from happening, I think, not the lack of technology and instruments and stuff that we can do at the moment. So I think we need to get over that barrier before we can explore the limitations we have on the technology side.
So a very straightforward way would be to collect bathymetry LiDAR.
Mm-hmm.
That could work very well in shallow water in the Falklands, but it's expensive. And
Yes. Well, talk to the UK Hydrographic Office. They might be able to get some funding to come to the Falklands and do that for you. I can...
They will.
See?
We did, and they will, but we have to decide where we want them to go.
So you need to decide where.
Prioritise.
So it's down to you to do the prioritisation. There we go. So it's happening.